Have you ever wondered why just by replacing hydrogen present in acetic acid with chlorine atom makes chloroacetic acid much stronger acid? Today, let's decode the real reason behind it. Hi, I'm Dr. Swathi, your organic chemistry coach, and in this video, we will explore why carboxylic acids are acidic in nature and how this acidity is measured and how the inductive effect of chlorine makes chloroacetic acid stronger acid than acetic acid. Now let's jump into the topic. We know that carboxylic acids are acidic in nature. So the acidic property of carboxylic acids is mainly because of their ability to lose protons. So carboxylic acids, they will lose protons and they will give corresponding carboxylate anion. So here the acidity of carboxylic acids is expressed in terms of pKa. So if you see what is the relationship between the acidity and the pKa, lower the pKa values, stronger the acid. So let us consider an example for this. So here this is chloroacetic acid structure and this is acetic acid. Chloroacetic acid pKa value is around 2.87 while acetic acid pKa value is 4.76. So by the thumb rule, that is lower the pKa value, stronger the acid, we can easily make out that chloroacetic acid is strongly acidic when compared with acetic acid. Now let us see what makes chloroacetic acid as a stronger acid when compared with acetic acid. So here carboxylic acid acidity, it depends on the stability of the carboxylate ion. Because when a carboxylic acid can readily lose its protons is when the resulting carboxylate ion is highly stable. Then it can immediately release the protons. Now let us try to understand the stability of the carboxylate ion in terms of its structure. So this is the structure of carboxylate ion RCOO-. Okay, so this has one more resonance structure. When we transfer this pair of electrons which are present on the second oxygen in the form of a double bond, then immediately the double bonded electrons will migrate in the form of electron pair onto the first oxygen. So that the first oxygen gets the negative charge and the second oxygen, there will be double bond formation with the carbon. So just what we have done, we have shifted this double bond to here and this single bond is shifted to here and thus oxygen is attaining the negative charge. Okay, so these are the two resulting carboxylate ion structures. Okay, now these two carboxylate ion structures, if you put together, we will get the corresponding resonance hybrid. So in one structure, one oxygen is having double bond, while in another structure, another oxygen is attaining the double bond. So if you put them together, then we can show like this. That is, we are representing a partial double bond over both the carbon atoms and represented with a minus symbol like this. So this is the resulting resonance hybrid structure. So it is because of this resonance stabilization, the resulting carboxylate ions will be stable. And thus carboxylic acids exhibit acidic property. So entire thing here, the stability of carboxylate ion is important. Among various types of carboxylic acids, which of the carboxylic acid, it generates highly stable carboxylate ion, that carboxylic acid will be strongly acidic in nature. Now let's consider the stability of carboxylate ions in case of chloroacetic acid and acetic acid. Chloroacetic acid, upon releasing protons, it generates corresponding chloroacetate ions. So this is the structure of chloroacetate ion. So this ion is having chlorine. Chlorine is an electron withdrawing group and it shows minus I effect. Chlorine being electron withdrawing group, it will try to take up the electron cloud from the alpha carbon. So the electrons will be, this bonded electrons will be more moved towards the chlorine, due to which there will be generation of partial positive charge on the alpha carbon of the chloroacetic acid. To compensate the partial positive charge on the alpha carbon, immediately the electron density which is present on the carboxylate ion will be dispersed over alpha carbon. That means due to the electron withdrawing effect of chlorine, the negative charge of the carboxylate ion will be dispersed over the molecule. So this dispersal of negative charge stabilizes the resulting carboxylate ion in case of chloroacetic acid. So as chloroacetic acid results in the formation of highly stable carboxylate ion, it is strongly acidic in nature. In case of acetic acid also being carboxylic acid in nature, it releases protons upon formation of acetate ions. Now if you look at the stability of acetate ions, so these acetate ions are having methyl group, which is an electron releasing group, and also it produces plus I effect, that is positive inductive effect. So because of this electron releasing group, the bonded pair of electrons which are present between the carbon of methyl group and carboxylate ion will be more pushed towards the carboxylate ion because methyl group is an electron donating or releasing group. So the electrons will be donated towards the carboxylate ion. And this carboxylate ion is already rich in electrons. COO minus charge, resonance stabilization is there. So further there is pushing of electron density from the methyl group side also. So that causes intensification of negative charge on the resulting carboxylate ion in case of acetic acid. So this intensification of negative charge destabilizes the resulting ion. So that is the reason the acetate ion which is formed upon deprotonation of acetic acid is less stable when compared with chloroacetic acid. Because it is less stable, it is weaker acid. So in case of chloroacetic acid, the resulting carboxylate ion is stabilized due to the presence of electron donating chlorine group which causes dispersal of the negative charge. So it stabilizes the resulting ion. While in case of acetic acid, the resulting carboxylate ion is having methyl group which is an electron releasing group which causes intensification of negative charge and thus it is destabilizing the resulting ion. It is because of that reason chloroacetic acid is stronger acid when compared with acetic acid. So the difference in acidity of various carboxylic acids is due to the presence of the substituents which are present in those molecules. Some of those substituents will be exhibiting positive inductive effect while some of the substituents present in carboxylic acids will be exhibiting negative inductive effect. It is because of these substituents, the stability of the resulting carboxylate ions will vary. If you found this explanation is useful to you, then give it a like and subscribe my channel and share to your friends also. For a deeper understanding, check out a detailed video on inductive effect which is already available on my channel. Thanks for watching. Stay tuned to my next videos.